There we go. All right. So you should have taken notes on it. Okay, if you did, what were the 4 ways to represent relations? Taylor, give me one. Ordered pairs. Joel, give me another one. Mapping. Garrett, give me another one. Graphing. Brooke, give me the last one. Table. All right. Those were the 4. What was the test that will tell us if our relation is a function or not? Aiden. Vertical line test. Good. So today we're going to put all of that stuff into practice and use that. So we're going to start with representing relations, identify the domain and range of the given relation, then represent the relation using a graph and a mapping diagram. So there are 3 parts to this. Okay, you're given the ordered pairs, so we're going to say the domain and range, and then we're making a graph and a mapping diagram. So this is page 76. Starting with number 6, -7, 4, 2, -5, 1, -2, and -3, 6. Okay, and we don't have any repeat values in this one for the domain and stuff, but if we were to have repeat values, okay, when you're doing like the domain and range, you don't list them more than once. So if like, say -7 was the x-coordinate for like 2 of the ordered pairs, you'd only list it once. Okay, so that's going to be like a big thing. That's a big mistake that I see a lot. So first of all, the domain. What was the domain values? X or Y? X values. So what are my X values for my domain? Yep. So that's my domain values. My range is what? Four, -5, -2, and 6. Alright, and really we should write them in like numerical order, like -5, and then -2, then 4, then 6. Okay, we should have done that with the domain, but as long as you get them down, that's fine. Alright, so then the next thing says to represent the relation using a graph. So we're going to graph these points on a coordinate axis. Don't care. You can literally just eyeball it. I really don't care. Alright, so describe to me where the first point should go. Up 2? Okay, so somewhere in that area. Alright, what's the next one? Next one? Last one? They're not aligned. Yeah, do not connect the points. Do not. Yes, if you did, it would be a little crazy. But don't connect them. That's another very common mistake that people make. And I do take points off for that. Don't connect them. Alright. Then the last part says to make a mapping diagram. So can anybody describe to me how that is set up? Yep. And I want to do them in, like in order. Okay, so for the inputs, I would want to start with -7, and then I would do -3, and then 1 and 2. Okay, so we want them to be like in number order. And then remember, we circle them as one thing here. Then my outputs, I'm going to do the same thing. So I have, let's see, -5, -2, 4, and 6. And I'm going to circle those. And then I'm going to use a different color to connect them. If y'all want to use a different color, you can. So now I'm drawing the lines between the points. So I had -7, 4. So -7 to 4 gets a line. Let's see, -3 to 6. 1 to -2. And 2 to -5. Yep, you would just write it once. If you had the 2 -5s, you would just write it once, and then you would, like let's say -3 went to -5 and 2 went to -5, then both of them would be drawn there. Any questions about that? Do we feel like we need to see another one of that kind, or do we feel okay about that? Okay. Then moving forward, the next thing says to, basically you're given a mapping diagram like this. This is for 10 through 13. It says tell whether the relation is a function, and then to explain. So starting with number 10. Okay, so 10 gives you the input and the output of -6, -4, -1, 2, 5, 2, 1, -1, and they didn't do them in order, but that's okay. And then they have them connected, all of them just straight across. So when we had points, how did I say in the video that we knew if it was a function or not? Yes. If each input has exactly one output, does each input have exactly one output here? Okay, so then is it a function? Yes, so this one's a function. Nope. You just have to tell me if it is or is not a function. And you don't have to copy the table over. Okay, I'm not going to make you do that. Let's see. How about 12 input, output, -1, 5, 4, 2, -1, -3. And they have -1 going to 2 and -1. They have 5 going to 4 and -3. Not a function, why not? Yep, each input has more than one output. Okay, and if you want a shortened way to write function, FNCT is how you can do that. One more really quick here that's not in your book, but just that I want to talk about. I'm running out of space at the bottom. Is this a function? Who says yes, it's a function? Who says no, it's not a function? There's some people that did not raise their hand for either one. Again, who said yes? Everybody says yes? No? Do I have any no's? Okay. So, for those of you who said yes, why would you say yes? Yes, each input has one output. Outputs can have more than one thing going to them, but the inputs can only have one. So if there's more than one line leaving your input value, it's not a function. So this one would be a function. Okay. Let's see. The next problems are like 16 through 19. They say tell whether the relation is a function. So they give you a bunch of ordered pairs again. So like 18, 0, 1, 1, 0, 2, 3, 3, 2, 4, 4. So, how do I set this up? Yep, mapping is a good way to do this one. So I have my input, output, what goes under each one. That's one you can use your calculator for. I trust you. You can go ahead and grab it. All right, and then now what do I do? There's a 0 right there. Technically, yes, but it's fine. All right, so now I need to not forget my little circles. Now I need to connect them. So what connects to each other? Is this a function? Okay, yes, it is a function. Okay, so for problems like this, you don't necessarily have to write down the ordered pairs, but you do have to make this mapping diagram. Okay, if you choose to do it a different way other than a mapping diagram, which I don't really know why you'd pick a different way because this is the easiest way, but if you do choose to do something else, you have to show me the way that you're testing it, and then you have to tell me if it is a function or not. Okay, so those are the two things I'm looking for with that type. Do we need to do another one of those, or are we okay with that? We're okay with that? Okay. Let's see. The next ones. Hold on, I'm trying to see. Okay, so then there's some graphs like 21 through 23. Okay, it wants us to test and see if these are functions. So 22 looks something like that. And it wants us to use the vertical line test to tell whether the relation is a function. So how would I test that? This way? Okay, so I just swipe it across. If at any point I have two places where it intersects, it's not a function. But if it only intersects my pen, the easiest way is to do it with your pen. You don't even have to draw the line. If it does not intersect anywhere with your pen more than one time, then it is a function. Yes, it's a vertical line test. I will tell you there is a horizontal line test to test for something else, but you don't get that till like pre-cal. Yeah, so yeah, it has to be vertical. That's why it's a vertical line test. All right. Yes. All right. So trying to think of what I gave you. Alright, so now I run my pen across it. Is this a function? Not a function, okay, that intersects in 4 spots, okay, but if it just intersected in 2, okay, it would be not a function as well. How about not a function, okay, it intersects in 2 places all the way, so. But if there's even one spot that it intersects in 2 places and say that's the only thing, it's still not a function, okay, even if there's only like one. Yes, because like right at the edge of this circle, technically there's probably only one point there that's intersecting. But as you move across, it hits in 2. So, and it would also depend on which way the semicircle is going. If it's just this top half, then it would be. But if it's the side half, it would not be. Does that kind of make sense overall? Okay. The vertical line test, like, it sounds like really weird and complicated, but once you actually do it, you're like, this is actually pretty easy. I presume y'all know how to graph lines. Okay. So we're not going to do that. So then the last stuff we need to look at really quick is determining if the function is linear. So, what did we say a linear function can be written as? F of x, okay, or what's the actual equation going to be? Oh, no, f of x, that's what, yeah, f parentheses x is f of x, is equal to what? Yes, but then what is that equal to? Yes, mx plus b. Yes. Okay, a linear function is something that can be written in the form y is equal to mx plus b. Okay, b could be 0, so it could just be like mx. M could be 1, so it could just be x. Okay, but something like that. Well, that's why we're going to go over them. Alright, so we're going to first tell whether the function is linear, and then we're going to evaluate the function for the given value of x. Okay, notice there's 2 instructions here of things to do. We're deciding if it's linear, and then we're deciding if, or then we're plugging in the value to check it. So, 34. F of x is equal to x plus 15, and then we're going to evaluate it for f of 8. Okay? So first of all, is this linear? Why? Yes. Okay, because I have an m is just 1, x plus b, so this is a line, so it's linear. Not on this one. If I told you to graph this, what would it look like? The diagonal line going up. Okay, you start here. Okay, this is in the form y is equal to mx plus b. I think what's throwing you guys off is this f of x. Probably. M is 1 in this case. There's an imaginary 1 here. Okay. Because mx plus b is a line. Yes, we're getting there. I was just stopping on the first one because we looked really confused. Yes, we do. Thank you. I just was going to keep going because they were asking me questions about that. All right, so plugging it in then. F of 8 is equal to, we replace the x with 8 plus 15. 8 plus 15, I already heard, is 23, and that's your answer. No. X is 8. X is 8. Okay, this is f of x. Okay, when you have something like this, I know you guys probably haven't seen this before. When you have something that's written f of x, okay, that means the function of x. Okay, so whatever x is equal to, okay, so in this case x is 8. So everywhere we see x in the equation, we put an 8. So we're evaluating the function basically for x is equal to 8, and we want to know what y is equal to. We're going to do more of them. Okay, we're not just going to stop here. All right. 36 is f of x is equal to the absolute value of x plus 10. What does an absolute value graph look like? It has 2 lines, so what does that mean? It's not linear. Okay, this graph looks something like, if this is 10, this graph looks something approximately like this. No, you don't. I'm just showing you why it's not linear. Yeah, it's not linear, but we're still solving the function. So then now, f of negative 4 is equal to the absolute value of negative 4 plus 10. What is that equal to? Okay, yes, so this becomes positive. So that's equal to 14. Okay, not linear, and 14 would be your answer. If it's anything other than other than f of x is equal to mx plus b, it's not linear. All right, another one, really quick, just to make sure we're good. This will be the last one, unless y'all have questions. Then obviously we can do another one or something. But 38 g of x. Okay, this means the same thing as f of x, f g. Those are 2 common functions. Okay, don't let the g throw you off. It means the exact same thing. Just what math people have chosen. It can be anything. You can have like t of x if you want, but the most common ones are f, g, and h. All right, g of x is equal to x cubed minus 2x squared plus 5x minus 8, g of negative 5. Okay. A cubic function, okay, this is obviously going to be a weird cubic function, but I'm just going to draw what the parent cubic function looks like. Okay, it looks something like that. Is that a straight line? No, so it is not linear. Because I know what it is, but it's not in the form mx plus b or mx minus b. If I took this part off and just had 5x minus 8, it would be linear. Okay, it's just linear with a negative b. Okay, so this is not linear. And now we need to plug it in and solve it. The g of negative 5 is equal to negative 5 cubed minus 2 times, I'm not going to fit this all here, 2 times negative 5 squared plus 5 times negative 5 minus 8. What's negative 5 cubed? Negative 125. 5 squared. Negative 5 squared. 25 times negative 2? Negative 50. 5 times negative 5? And then what does that give me? Correct, not linear. Okay. Any more questions? Alright, so then your in-class work, about 15 minutes. I'm not giving you a ton of them, though. I am going to give you 5, 11, 17, 21, and 35. So just 5 problems. Okay, just make sure you show the different diagrams and stuff correctly, like the way I explained to you to show them. Okay, that's going to be the biggest thing with this. No, you don't have to explain it. Don't do the explain, just tell me if it's a function or not. Assuming you're which ones are you talking about? 11, you just tell me if it's a function or not. 17, you're going to show me like the mapping diagram, and that's going to give me your reason right there. So you're just going to tell me it is or isn't a function, and then show me the diagram. Okay.